Welcome, curious minds, to another deep dive.
Great to be here.
Today, we're setting our sights on, well, a real cosmic enigma. It truly defines the giant of our solar system, Jupiter's Great Red Spot. Our mission. Let's try and peel back some of the layers of mystery surrounding this colossal, incredibly long-standing storm.
Yeah.
We've pulled together some really compelling sources for this, and they reveal not just what this thing is, but why it's so unique, and maybe most fascinatingly, what's happening to it, like, right now.
It's an absolutely captivating topic. And
Right.
you're right, the sheer scale and, the almost unbelievable longevity of the Great Red Spot,
Yeah.
it makes it a profound puzzle in planetary science.
Right.
So yeah, prepare yourselves for some surprising insights and hopefully a few mind-bending revelations as we explore what makes this storm tick and maybe what its evolving future might tell us.
Okay, so let's kick things off with Jupiter itself, the king of planets, right?
The gas giant.
It's a gas giant, meaning, well, no solid surface to speak of. Essentially a world of just perpetual atmospheric churn.
Constant storms, basically.
And amidst all that swirling chaos, one feature just stands out above everything else, doesn't it? Dominating the southern hemisphere.
Precisely. We're talking about what people often call the Eye of Jupiter, the Great Red Spot.
The Eye of Jupiter.
Yeah. And just try to picture this. A storm so immense that it's genuinely wider than our entire Earth.
Wider than Earth.
And it's been raging for centuries without just fizzling out.
That scale it's almost impossible to grasp. A storm bigger than our whole planet. Can you describe its, like, fundamental nature for us? What is it?
Okay, so at its core, it's a colossal anticyclone. Think of it like a hurricane on Earth, but just scaled up to an absolutely unimaginable degree. Its winds regularly get over 400 kilometers per hour. That's, what, about 250 miles per hour?
Wow.
But its true mystery isn't just the size, it's the incredible longevity.
Yeah.
I mean, astronomers have solid observations, continuous ones, for nearly 200 years.
200.
And evidence suggests it was likely around for at least 300, maybe 400 years before that, possibly even longer. We don't know for sure how far back it goes.
Centuries. That's the really mind-boggling part. Because on Earth, right, even our biggest, baddest hurricanes, they hit land or cooler water and they dissipate. Weeks, maybe.
And they run out of steam pretty quick.
So how does a storm manage that? How does it just keep going for potentially hundreds of years? Let's unpack this.
Right, that's the first huge mystery.
Yeah.
And the answer really boils down to how fundamentally different Jupiter is from Earth. There are kind of three key things.
Yeah.
First, as you mentioned, there's no solid surface on Jupiter, zero.
Right.
On Earth, friction with land, that's what really saps the energy from storms. It slows them down, breaks them apart.
Yeah.
But on Jupiter, the Great Red Spot just churns. It moves freely in the atmosphere with absolutely nothing solid underneath to act like a brake.
So it's like a storm with no brakes, essentially. It just keeps rolling.
Exactly. Second, it's constantly getting fueled from below. Jupiter generates immense heat deep in its core, way more than it gets from the sun. And this heat drives these powerful convection currents, constantly churning the atmosphere. It acts like a continuous energy source, a sort of perpetual engine for the storm.
A planetary engine keeping it alive. Okay.
And then the third thing, which is really fascinating, the Great Red Spot essentially feeds itself.
Feeds itself.
Well, the astronomers have actually seen it happen. It basically swallows smaller storms, smaller vortices that drift into its path. It absorbs their energy, their momentum, their mass.
Wow.
And uses that to maintain its own colossal strength. You could almost describe it as a predatory storm.
A predatory storm swallowing its neighbors. That's
Yeah.
quite an image. So Jupiter's whole environment, no land, internal heat, eating smaller storms, it creates this perfect cradle for a storm like this to just endure.
Pretty much, yeah. It's a unique set of conditions.
Yet, even something this ancient, this immense, it isn't static, is it? You mentioned recent observations point to a shift.
That's right.
For the last century or so, scientists have noticed something. Well, maybe alarming. The Great Red Spot is shrinking.
It is, yes.
Shrinking? I mean, does that mean this cosmic titan is finally dying after all this time?
That is the big question everyone's asking right now. And it's a definite change from its history. Back in the late 1800s, when we first got good measurements, this storm was vast, about 3 times wider than the Earth.
3 times Earth's diameter.
Yeah, huge. today. It's only a little bit wider than our planet. It's still big, obviously, but significantly smaller.
Wow, that's a huge change.
And its shape is changing, too. It used to be a very distinct, long oval. Now it's becoming much more circular. And, yeah, based on this trend, some scientists do believe it could potentially, vanish entirely, maybe within the next few decades.
Vanish? But why? After surviving for centuries, what could possibly be causing it to shrink now? This is where it gets really interesting, isn't it?
It absolutely is. And the honest answer is we don't know for sure yet, but there are theories.
Okay, like what?
Well, one possibility is that the atmospheric dynamics around it are changing. The currents, the atmospheric jets that sort of confine it and maybe feed it, perhaps they're shifting subtly over time, changing the energy balance.
So the weather patterns on Jupiter are evolving.
Could be. On a very long time scale, yes. But there's another theory, which I find particularly fascinating.
Yeah.
Maybe it's not actually dying at all. Maybe it's just transforming.
Transforming how?
Recent observations, especially from missions like Juno, suggest that while it's shrinking in width horizontally, it might actually be growing taller, vertically, stretching upwards, deeper into Jupiter's atmosphere.
Oh, interesting. So it's trading breadth for height in a way.
That's the idea. Sacrificing its horizontal footprint, but maybe becoming more vertically intense or stable in a different way.
So it could be evolving into something new, a different kind of long-lived atmospheric structure that maybe we just haven't recognized before.
Precisely. It might not be a decline, but a long-term transformation. Maybe it's adapting to slightly different atmospheric conditions than existed, say, 200 years ago. It really challenges our assumptions about what stability even means for a feature like this, which is inherently dynamic.
It really does. The idea that even something that seems so ancient, so permanent, like the Great Red Spot, is undergoing this kind of change right before our eyes.
It connects back to a broader insight, doesn't it?
Yeah.
That the universe is in constant flux. Even things that appear unchanging over human timescales are often part of a much longer, slower evolution.
Yeah, absolutely. This ancient storm on Jupiter, it's not just some static postcard picture. It's like this giant, almost living creature living its own long, slow life, changing over centuries.
Oh, good analogy.
And it's a powerful reminder, I think, that even in what looks like the most violent chaos, there's this magnificent order, this beauty playing out on a scale we can barely even comprehend.
Well said.
It really makes you wonder, doesn't it? What else? What other seemingly permanent features out there in the vastness of the cosmos, or maybe even closer to home in ways we don't notice? What else might be undergoing its own grand, slow, magnificent transformation, just waiting for us to look closely enough? Something to ponder.